was in March 2016 that we have received an email from a company ATS from New Zealand, and they were asking us whether we would be interested to find out whether their electroseismic method would be applicable to salt. And we said yes. The place we had in mind is in north of Switzerland, where the Swiss salt works operate an evaporating plant, and for the evaporation they obtain brine by solution mining from the surrounding fields. This is Switzerland, this is the village Riburg, this is the evaporating plant, here is the River Rhine, and here is the site that we have selected for the test. The site that we have selected is known to have salt deposits. The solution mining is being done there now since many years, perhaps even centuries. And the geological profile of the salt deposit is very well known. So we have selected this place, and we have determined about 30 points where the electroseismic mapping will be done. The electroseismic method works on the principle of creating a seismic wave The seismic wave hits some underground geological formations, which then respond with electromagnetic waves. The electromagnetic signal is being detected by two electrodes driven into the Earth's surface, about half a meter deep. And these electrodes are connected to a recorder. The recordings of the electroseismic response are then evaluated using a computer program. We have received the approval to do this measurement from Carlo Habich, who happens to be the sales manager of industrial salt of Salt Works. He and his family own this land and the farmhouse in the neighborhood. The recordings were sent to the company ATS for evaluation, and they have created a 3D model from these measurements. We have also received the information regarding the location and thickness of the salt deposit, which was carried out by boreholes and evaluation of core samples in 1, 2, 3, 4, 5, 6, 7, 8 points. The model itself of the electroseismic measurements is shown here, and you can see that the top of the salt layer is being very precisely determined. This change of conductivity is explained by diffusion of sodium chloride through the gypsum cap rock on top of the salt, which protects the salt against dissolution by underground water present in the overlying formation. Similar effect is also at the bottom, where also some less saline waters are present and the salinity changes. Now, this is a side view, and When we move this model, we can see the top layer of the salt in three-dimensional form. The advantage of the electroseismic method is that you only need to do one borehole, and the rest of the area that you investigate is done by the electroseismic method. A borehole down to a depth of 300 meters, as it was done here, may take a day, 2 or several days. The electroseismic method was able to carry out 29 measurements just in one day. So you can imagine what savings in cost and in the speed of the investigation you can achieve with this method.